Okay. So let's try this again at a different point. So we've got f of x and y is 4 minus x squared minus 2y squared. And we want to base the Taylor series around 1, 2. Okay, so what did you guys get?
I did look at the points.
So I probably should use soft equals, right?
Yeah.
Okay, and I should plug in 1, 2. What do you get? Negative what? Negative what?
4 times 2 is negative 8 minus 1.
Plus
Negative 5, yeah.
negative 5. Okay. Survey says negative 5.
I did 2 times 2 and then squared.
You guys are bad at arithmetic. All right.
Well,
So,
I just gotta fix some numbers now.
and so for testing, right, I would advise that you write down where you got that number so that I can at least give you partial credit if your arithmetic sucks. So that's f of 1, 2, right? If you put that above there, I'm giving you most of the points. If you don't put that above there, I'm like, where did you get negative 13? Okay, so I got f of 1, 2 plus, what's your next term?
I have no confidence.
No confidence.
Partial
No.
x, partial y.
Okay, so I need fx and fy, right?
I know.
Negative 2x and negative 4y.
So we did those before. And then I need, where do I need to evaluate these?
At 1,
1, 2.
At 1, 2. Okay, so what's fx at 1, 2?
Negative 2.
Negative 2. So I got negative 2 times
X minus 1.
x minus 1. Okay, so that looks like fx at 1, 2 times delta x. Alright. Okay, what's your next one?
Plus negative
4.
Negative
8.
8.
Oh, yeah.
Right, because I need to evaluate this at 1, 2.
Yeah.
So the x is 1, which doesn't matter, but the y is 2. I got negative 8 times y minus
2.
2. Okay, so what's this thing right now? What have I got here?
Your first root.
Yeah, this is a first order Taylor polynomial, right? Which is the tangent blank. Yeah, you guys see that? This thing, right, is the tangent point. Okay. So then what's your next bit? You need fxx, which is negative 2. That's convenient, right? Because it doesn't matter where I'm evaluating. Fyy, which is negative 4, also doesn't matter where you're evaluating. And
fxy and fyi.
okay, perfect. The other two are equal and 0, so I don't need those. Okay, so I need to add here, there should be 4 terms, right? But I don't need 2 of them.
Because they're 0.
Because they're 0 from this. So how about the other 2? So I got minus 2 times the quantity
X minus 1 quantity squared.
x minus 1 squared.
Over 2.
And then I need over 2. Good.
And then plus
Plus
negative 4
negative 4
x minus
Y minus 1.
and y minus yeah
times y minus 2 squared
over 2.
all over 2. And then really I should write here also plus 0 times x times, what would those be? Those would be times 0 over 2 times,
Cube.
X minus 1 y minus
perfect, x minus 1 and y minus 2, right?
Where'd you get the xy equals 0 and y?
These guys? That's taking the, so here I want to take the y derivative of this thing.
but it's a constant.
That's all constant with respect
Okay.
to y, so I get 0. Or here I want to take the x derivative. Again, this stuff's all constant with respect to the opposite variable. Cool? Cool. So you get this plus similar 0, right? So here's your second degree Taylor approximation. All this stuff.
You wouldn't FOIL it out and combine stuff?
If you FOIL it out and combine stuff, what will you get?
The original function.
You will get back the original function.
That
Because
was my question.
this thing is a second order function, right? This is a second order polynomial.
Mm-hmm.
And so if I make a second order approximation to it, it's not an approximation. It is actually the same thing. You guys see that? So don't be surprised when if you're approximating a polynomial, right? The best approximation for a polynomial is still going to be that polynomial.
But here, if you look at the negative 2 times quantity x minus 1 squared over 2, that'd just be negative 1 times.
Yep.
You'll have a negative, what, 2?
Yeah, so I'll have a negative
No,
x
oh, you get a
squared,
positive
right?
2x, and then okay.
And then I'll get something
Okay.
that'll cancel with this guy.
Yeah.
Yeah. It's all there. Cool? Check. This goes back to the famous mathematician who said the best model for a cat is a cat, preferably the same cat. Right? So when you're trying to model cats, don't be surprised when the model you get looks a lot like a cat. And if your thing happens to be of convenient form, right, you will get in fact the same thing back.